Command handlers calling other commands. This is something I come across often and have done myself when building message-based applications. Now, this often leads to tight coupling, code duplication, and makes it hard to add new features to our application. It also violates the open-closed principle. In this video, let's learn the different problems that's caused by calling other commands from our command handlers and what you can do to fix them and to make our application loosely coupled. Hello, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos mostly around .NET and this video is part of my messaging series. This video is sponsored by AWS and I will be using some of the AWS services to explain the messaging concepts. However, this is applicable to any other cloud provider or messaging systems that you might be using, like Azure Service Bus, RabbitMQ, etc. So without much delay, let's learn why calling other commands in your command handlers might not be a good idea. Here, I have an existing application which I have been using in my messaging series, which I have slightly modified for this example. So I'll have a quick walkthrough of that. Here we have the weather forecast controller, which takes in a request to post a new weather forecast. So it takes in the create weather forecast command and it sends the create weather forecast command. Now we have published this to a queue, which is the weather data service. This is an AWS SQS queue. Now if you're using Azure, this might be an Azure queue or a Service Bus queue or even a RabbitMQ. Now once the message is dropped into the queue, we have a background processor, which is the weather forecast processor that listens on that queue and it pulls down the message and processes it. All this does right now is to deserialize the command and convert it to a weather forecast and save it into the database. Now when this happens, we also need to send an email to a specific email address. So we call the send email command right after saving the database item. Now all this does is create a send email command, converts the weather forecast into an email format and publishes it again to a queue. Now this is getting processed by our email processor, which picks up the message and sends an email using the SendGrid API. Now I walked through most of this in my previous two videos in this series. Now if any of this is confusing for you, I highly recommend checking that out before looking at this video. If you come back to the weather forecast processor, you can see that we are calling the send email command. Now this by itself is a command handler which is sending another command. Now let's say as the business grows, we want to add new features to the application and we want to send an SMS as well while sending an email command. Now since we are already sending an email command here, we will be really tempted to add in a send SMS command and do the similar functionality. So we'll have to come and modify our weather forecast processor and call the send SMS command. Similar way, if you want to do other features, let's say we want to rerun a report, we would be coming in here and again adding rerun the report or trigger the report command, etc. and adding more commands inside this weather forecast processor. So we are having to modify this existing weather forecast processor, which was doing its job perfectly well until we had to add new features. This violates the open-closed principle. The open-closed principles, or OCP, is one of the solid object-oriented design principles. It states that software entities, which can be classes, functions, modules, should be open for extension and closed for modification, which means you should be able to add new features to existing source code without having to modify their code, but by extending them. Now in these cases, we have been actually modifying the existing code and not extending them. So let's comment out these two lines for now and come back to how we will solve this. The other problem with having the command handlers calling the commands is code duplication. Let's say again the business comes and asks us to do a new feature, which is to do a bulk import of weather forecast. So we might be getting it as a file, or maybe there's an API which sends in a bulk of weather data and we need to process them. So we might come into a new controller or an existing controller and add a new endpoint. So let's say create bulk weather forecast command. And that's going to take data in different formats. It might be a file or it might be a list of weather forecast data. Now, when we create a processor for that command, we will have to duplicate a lot of these code inside there as well. Now, when we create the endpoint for that, so let's assume we have a new post endpoint. So we can duplicate this and let's say post bulk. So let's also add a new route for this. So let's say post bulk in this particular case. So if this is going to be a create bulk weather forecast command, so let's generate a new class create bulk weather forecast command, which might be taking in a I file as the input for this particular command. So let's assume all this exists and we read this and start processing this data. So once we have processed the data, we will have to duplicate much of this code to send the email, the SMS, and the run report, etc. And as we add new features, we will have to make sure to copy across all these commands that's getting called here onto the other endpoint or the processor as well. So in these cases, the code is getting duplicated in multiple places, and you will have to keep remembering to add all these commands that you are adding in both the places. Now, it's very common in different domains to have different ways to create the entities. Now, for example, if you're building an order, there might be an endpoint to create an order. There might also be an endpoint where you have to approve an order until which it will be a draft order. So you might be able to create the order in one place, but then there might be another place where you approve an order and it also becomes an order. So in these cases as well, you will end up duplicating these code in multiple places. And there is a high risk of losing functionality because you didn't copy over some of these code. Now let's see how we can solve this problem and avoid code duplication, avoid breaking the OCP principle, etc. So let's come back to the controller. Let's remove this post bulk and let's just comment it out for now. If we come back to our weather forecast processor, rather than calling the send email command here, we need to publish an event. And the sending the email should be a response to that event. Even if you talk to the business, they would be using similar terms. When and weather forecast data is published or added, we need to notify certain users. This might be via email, SMS, or we might even have to run a few other reports, etc. The idea here is to capture the business language speak. So if we come here and rather than calling these commands right from here, all we need to do is publish the event. So let's go and create the weather forecast data created event, which is what is happening at this point. So let's create a new class. So let's come here and create a new class inside our project, and let's call this as weather forecast created event. Now note I'm using the convention of using event in the end of the classes and suffix commands to show that it is a command. So let's add two properties inside this. So inside the weather forecast processor, we have the city name and the date. So these are the two properties that's required to look up a weather forecast. So let's copy both of that and add this into our weather forecast event. So let's create them and we should be good to go. Now, anytime the weather forecast processor is done with saving this, we can create a new event. So let's say weather event is equal to new weather forecast created event, and let's pass in both this data. So in this case, this is going to be the city name command.cityname and the date, which is the command.date. Now, once we have the event, we need to publish this event. This is where we use a different infrastructure, which is the Amazon SQS, which follows the topics and subscriptions model. Amazon SQS is commonly used for a pub/sub kind of a model. A similar offering from Azure is the Azure Service Bus. If you're new to either of these, I have videos in this channel and will also be in the descriptions below. So let's use the topic and publish this event to this specific topic. So if I navigate to my AWS console, under the SNS, I can grab the topic that I have already created. Now I have the weather forecast topic, and I can copy this particular ARN and publish the details into this topic. So let's come back to our code and publish this event to the topic. Now I already have set up this controller to inject in the iAmazon simple notification service. Now this is set up inside the program.cs and dependency injected into the container. So we are injecting the Amazon Simple Notification Service client, which is automatically wired up to this particular interface. So let's come back and use this to publish the event. So let's call the Amazon SNS client and let's call the publish async method. Now in this case, this takes a publish request. So let's create a new publish request and let's pass in the appropriate information. In this case, this will be requiring the topic ARN. So let's pass in the topic ARN, which we just copied from the AWS console. And let's also pass in the message. Now all we need to do is to JSON serialize this particular message. So just use the JSON serializer, .serialize and serialize the weather event. So let's pass in the weather event and that message will be published. So let's make sure to do that. Let's remove both this code which sends the email, SMS, etc. from our code. Our weather forecast processor or the command handler is not sending any more commands. All it's doing is just publishing the thing that has happened or what it was responsible for. In this case, creating the weather forecast object. So once this is published, we can set up the email processor to listen to this topic. So if we come back to the topic inside the Amazon console, I have already set up the subscriptions for these. Now in this particular case, I have set up an SQS subscription so that anytime a message is dropped into this topic, it will be automatically forwarded to these queues. Now if you navigate to these, you can see these queues inside here. In this particular case, this is sending the message to the email service queue. I also have another subscription which sends it to the SMS service queue. So anytime we have the message coming into this particular topic, what happens is the same message gets duplicated and sent to this particular queue, and also a copy gets sent to this queue. Now, as you have more subscriptions, let's say you want to add a report, you would be adding more subscriptions in here and the message will get copied over to the new subscriptions. Now, one thing you need to know, only the messages that's published after you have created a subscription will get sent to that particular subscription. So the old messages will not be sent to subscriptions that are newly created. Now, once we have all of this set up and publish the message into this ARN, in this particular case, this will get forwarded to the email queue. So let's come back to our code inside the email processor. So if we look at the email processor, this before was deserializing it as the send email command. Now no longer is it getting this. So in this particular case, this will be getting the weather forecast created event. So we are going to respond to this particular event. Anytime a weather forecast is created, I need to send an email. That is a responsibility of the email processor. So let's deserialize this into an event. So let's rename this as weather forecast created event. Now, once we have the event, we need to get the data for this particular event. So we can use the weather forecast data. Let's use the DynamoDB context and load this specific item. So in this case, we need to load the weather forecast data. So let's pass in the appropriate information from the event. So let's pass it in the city name and also the date, which are the two keys on this particular object. Now this data is getting stored in DynamoDB, which is a NoSQL database. So this has a partition key and a range key. Now, if you're completely new to DynamoDB, I highly recommend checking out my video if you want to learn more about that. But this could be any database where your data is saved. This could be a SQL server. This could be an Azure Cosmos table or any other storage that you are using to save your data. Now, once you have retrieved the data, you can use that to send the email. So instead of creating the send email command, we will be directly sending the email inside this. So let's replace this with the weather forecast and let's pass in the data. Now, if I come back to the weather forecast processor, this already does the transformation on the weather forecast data. So let me simply copy this body subject onto my new processor. So let's remove this and let's paste this in. In this case, this is plain text content. So all this is doing is converting the data into a subject and also serializing the data as is into the text of the email. So we can also say the city if we want, so new weather data for city and pass the city name. So we can call the data.cityname. We also need the to address. So let's copy that from here. So once we copy that, we can put that inside here. So instead of the command.to, we will be directly putting the email address. Now, once this is done, we no longer need this particular code inside our weather forecast processor. So let's remove that from this piece of code. Now, this weather forecast processor no longer knows anything about the email or SMS or reports. All it cares about is saving the weather forecast data and notifying everybody else about that. So let's come back to our email processor. Inside here, there is a slight issue. So let's make sure to call the await on this DynamoDB context. So we are getting the actual object and passing that in. So let's build this and make sure it's building fine. And let's run this. So let's put a breakpoint inside here and also inside our weather forecast processor where it's going to raise the event. And let's run this application. Now I have the SendGrid API configured in my environment. Now if you're using this code, you will have to get your own API key and update it in your environment variables. Now let's click the weather forecast. Let's try it out. Let's specify the city name as Brisbane, which is where I'm currently living. And let's pass the temperature as 20. And let's click execute. Now this publishes the message into the SQS queue. So as soon as we create the data inside the database, we publish this event. Now once the event receives the topic, it sends a copy to both the queues where we have created the subscription. Now the email processor is listening on one of those queues, which is the email service queue, and picks up that up to process this particular event. So once it has retrieved the event, it gets the data for that particular event and it sends the email. Once it's successfully done, it removes the message from the queue. So let's continue this execution. Let's navigate to the mailinator where I have the email set up. So this is a public service where you can send emails. So this has the new weather data for city Brisbane, date, the specific date. Now, if we need to add an SMS notification, we don't need to come here and modify the weather forecast processor because this knows nothing about the email. So when we look at the email processor, we know that we have a queue, which means we need to just listen to the topic and add a new subscription and have that send the SMS. So let's go over here and let's create a copy of this email processor and let's call this as SMS processor. Now let's also rename this class. So let's rename this as SMS processor and let's make sure to fix the constructor name as well. Now once we have the SMS processor set up, we can go and get the queue details for the SMS service. So let's copy this queue and let's paste that in here. So let's remove the email service queue and make that as the SMS service queue. So when this service starts up, it's going to listen to this queue and get all the messages inside that. Now all we need to do is send the SMS. Since I don't have a phone number and a mock SMS service, I'm just going to pretend this as an email itself. So all I'm going to do is modify the subject and say pretend this as SMS. Now once that is done, let's build this and let's run this again. Now since the subscription already existed for my case, we are going to get an SMS message as soon as this application runs. So if I go to the mailinator, nothing has come. This is because I did not register the SMS processor. So let's stop this, go back to the program.cs, and let's also wire up the SMS processor. So let's copy this line and change this to be the SMS processor. Now, once this is done again, let's run this again and see if we get an email as soon as this runs. So let's go into the mailinator account. So let's copy into the URL. And now we have the pretend this as SMS email. This is because the subscription was created before I raised the first event, because of which that message was waiting there in the queue to be processed. As soon as I added a new processor for that queue, it picked it up and did what it had to do. Now, if I come and create a new weather entry, so let's do this for Sydney. And let's say it is 10 degrees there and let's click execute. So this raises the publish async. It calls the email processor and it also calls the SMS processor. Now if I come to mailinator, you can see there's two emails coming here. So this is the new email data and this is the SMS that we are pretending to be sent. Now if you want to rerun the report, you know exactly what to do. All we need to do is come here, create a new processor or a handler for that particular event and rerun the reports as required. Now, none of these cases did we do anything inside the weather forecast processor. We haven't modified any piece of code because none of these features affected the actual saving of the data. Now, if you want to change the way you save the data, or let's say you add more properties into this data, then of course you will have to change the weather forecast processor because you're actually changing the feature or adding capabilities to that specific feature. And in that case, it makes sense to modify that. But otherwise, you don't have to touch this particular handler. Even when you copy the controller, so let's say we come and create a post bulk endpoint, once you've created the weather forecast data in however format you want, you can simply raise the event which says weather forecast created event. And once that is raised, all these things will automatically happen because it's the same event that is going to be raised and we are listening to that to send emails, SMS, rerun reports, etc. I hope this helps you to understand why you should be avoiding calling other commands inside your command handlers. You should be raising domain events instead of calling other commands. Domain events makes the side effects more explicit and helps us build loosely coupled applications. You are able to add new features to the domain as and when requests come in and respond to existing events that you already have in your domain. This also makes it easier to talk to your business domain experts and have a common language when discussing these features. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.